right, part 2, here we go. Okay, the final stretch. So, solve each problem algebraically. Guys, we're doing the same thing we've been doing, but we're adding a little bit of a twist to it. Alright, so here I need to get everything equal to 0. Get equal to 0. Okay? Anytime we're trying to solve, we're going to equal 0. So here I've got for number 8, x to the 4th plus 6x squared minus 72 equals 0. This is a trinomial. Now, we went over this in class. We're playing the x game. Okay, negative 72 on top, 6 down low. Can you guys think of numbers that multiply to give you 72, okay, but add, or in this case, subtract to give you 6? So if you play around this a little bit, I believe it's 12 and 6, but I want 12 and negative 6, okay, because I want to get a positive 6. So when I break this up, here's the one thing that's different from before. Because it's x to the 4th, my leading coefficient now will become x squared. And I can go right into this because my leading coefficient's 1 here. If it was a bigger number, then I have to do my long process of doing factor by grouping. So I can put a plus 12 and then a minus 6 here. Alright, since I'm solving this, you make two separate equations. X squared plus 12 equals 0. X squared minus 6 equals 0. Alright, subtract 12 over, square root. Now, when I square root both sides of an equation, I need a plus or minus. I need to pull out an I, alright, because there's a negative there. And then this can be written down to 4 and 3. You still got to know your perfect squares. So I'm getting plus or minus 2I root 3. Okay, something that we've learned before. It's not going away. You'll be doing it the rest of the entire year. Over here, if I add over 6, this one's actually a little bit easier because when I square root it, there is no perfect square that goes into 6. So my answer is just plus or minus root 6. Okay. So there's my 4 answers. Plus or minus root 6, plus or minus 2I root 3. Okay? So don't forget your plus or minuses. I know it sounds silly, but it does matter. It's a very big deal. Okay, number 9, over here. Okay, so I'm getting everything on one side. Okay, so I have 2x to the 4th already on the left. I can subtract 10x to the 3rd over. I'm going to add 16x squared over. And then I already have a negative 80x over there. Just to take pause for a moment here, hopefully you guys are comfortable with what I just did. I'm trying to get everything on one side, but I'm also putting it in standard form where I have the highest exponent and the next highest exponent all the way down. In this problem, I get a little bit lucky because I have a GCF that can go into all 4 of them. I can pull out a 2x. If I divide everything by 2x, I'm left with x cubed minus 5x squared plus 8x minus 40. Okay, I'm just trying to make my life easier. And now I do my my factor by grouping. So the 2x is still just chilling out front. What can I pull out of x cubed minus 5x squared? Well, I can take out an x squared. And then I'm left with x minus 5. What can I pull out of negative 8x minus 40? Well, I can pull out a negative 8, which leaves me with x minus 5. Oops, my apologies, guys, because I saw this parentheses right here. This is a plus sign, so this needs to be plus 8. Sorry. Just had to pause the video right there. So this should be an x minus 5. Lo siento, okay? Alright, so the 2x is still chilling out front. The x minus 5 is common in both of them. And if I cover them up, I'm left with x squared plus 8. Alright, so we're looking good. This equals 0. I always like that one the best because it's super easy. Like, you just divide by 2. X is 0. Hooray. This equals 0. Solve for that. Add the 5 over. X equals 5. Hooray. And then x squared plus 8 equals 0. A little more work here. If I subtract the 8 over, I get x squared equals negative 8. Square root left, square root right. X equals plus or minus I root 4 times root 2. Okay, again, just perfect squares, breaking it down. Plus or minus 2I root 2. Good. Yes, I know this is a little frustrating with the whole square roots and everything else. Remember the I for negatives. Okay, only if it's negative. Remember plus or minus if you square root both sides. This is the meat of the problem up here, obviously. All right, and I mean, like, you still want to get full credit, so make sure you're taking your time and going through it. All righty? Cool. Okay, 10, 11. So here's 10. Another factor by grouping. So I've got x to the fourth on the left. I've got minus 2x cubed. If I add over the x and I subtract over the 2, there we go. I have 4 things, so I know I'm doing factor by grouping. Sorry I'm going a little fast. I'm just trying to get as many as I can. I can factor out x cubed here, which leaves me as x minus 2. Here I can take out a 1. Okay, cool. So now I've got x minus 2, x cubed plus 1. Alright, now, be careful. This would be an extremely difficult problem, but just to show you guys this is actually a sum of cubes. So we're doing the a and the b thing. The cubed root of x is, the cubed root of x cubed is x. The cubed root of 1 is 1. So if I follow my pattern, it's x plus 1, x squared minus 1x plus 1. Okay, so I'm going to make each of these things equal to 0. This one's easy. Make this one equal to 0. This one's easy. This one is a little bit rough because you can try to factor this, but it's not going to work. This is where we need quadratic formula. I'll give you guys a little bit of peace of mind. If you get one like this, we will give you quadratic formula on the test. If, I don't know if it is or not. Here's your A, B, C. So here we go. Negative of negative 1 is positive 1. Negative 1 squared minus 4 times 1 times 1 all over 2. Okay, so 1 plus or minus. All right, negative 1 squared is 1. Minus 4 is negative 3. Okay, just some calculator work. And the last thing here is I know we can't square root 3, but I can pull out an I because I don't want to leave a negative under the square root. Ta-da! Definitely a more involved problem. Okay, it's just quadratic formula. And again, we'll give this to you. If you run into one, you're really only going to run into one if you have a sum or difference of cubes and they make you solve it. Okay? Very good. And let's take a look here. Number 11 is actually kind of nice. All right. What's common in both 4x to the 5th minus 25x? Well, they both have an x. So if I pull that out, I'm left with 4x to the 4th minus 25. Now I'm hoping that you guys are getting a little better with this with a slow little ding going off in your head. 4 and 25 are both perfect squares. So this is a difference of squares problem. 2x squared plus 5, 2x squared minus 5. Okay. So I can make this equal to 0. Great. And then I can make this equal to 0. Alright. Here it gets a little tougher. 2x squared plus 5 equals 0. Bear with me. Subtract the 5 over. Divide by 2. So now I have negative 5 over 2. If I square root both sides, I'm going to get plus or minus I root 5 over root 2. Now, this is going back a ways, but you guys got to start getting good at this. I never want to square root in the denominator, so I have to rationalize it. You multiply top and bottom by root 2. So I get plus or minus root 10 with an I out front over 2. Root 2 times root 2 just gives me 2. You can't divide root 10 by 2 because one's under the square root, one's not. Good news over here, guys, if you can do that. All right, so I get 2x squared equals positive 5. The only thing different here is it's positive 5, so like it's going to be the same answer as this, but without the I. Plus or minus root 10 over 2. How did I jump that much? Well, I just skipped all the work. Don't reinvent the wheel. There you go. Okay. If you need help with this, ask one-on-one. I'll definitely help you guys, all right? Very good. Okay. Big problem at the end here. Let's go. The sides of a base of a pyramid are 6 meters less than 3 times the height of the pyramid. All right, so here we go. I've got roughly a pyramid that looks like this, okay? And what they're saying here is, it says the base of the pyramid is 3 times the height. Sorry, 6 meters less than 3 times the height. I'm going to call the height x. All right. This is going to be 3x minus 6 is the base of my pyramid. All right. That's just following the directions. The volume of the pyramid can be represented by volume equals 1/3 area of base times height, where b is the area of the base and h is the height of the pyramid. If the volume of the pyramid is 48 cubic meters, calculate the area of the base. All right, here we go. The volume is 48, so I put a 48 in for v. 1/3, the area of the base, guys. The base of a pyramid is a square, so it's 3x minus 6 times 3x minus 6. And the height is x. All right. I hate fractions. I'm getting rid of that 1/3 by multiplying both sides by 3. Okay, that cancels it out over there. And on the right, I'm going to get, okay, 48 times 3. Oop, that's 6. 144. Okay, now I have to FOIL. 3x times 3x is 9x squared. 3x times negative 6 is negative 18x. Negative 6 times 3x is negative 18x. And negative 6 times negative 6 is plus 36. All right, cool. Now, 144 equals 9x squared minus 36x plus 36. If I distribute that x in, okay, 144 equals 9x cubed minus 36x squared plus 36x. All right. Now, I know we did a lot right there, but I'm just going to make it equal to 0 now. So I'm going to have, let's see, 9x cubed minus 36x squared plus 36x minus 144 equals 0. Okay, so real quick, I'm just going to double check. Is 144 divisible by 9? Okay, 144 divisible by 9. That's not 9. All right, so check this out. Everything's divisible by 9. So I'm going to divide everything by 9 first. X cubed minus 4x squared plus 4x minus 16 equals 0. All right, I know you're probably freaking out right now thinking this is the hardest problem known to man, but honestly, guys, it's just a factor by grouping. I know you're good at this. So if I go ahead and do both of them, I can pull out an x squared. I'm left with x minus 4. I can pull out a plus 4, which leaves me with x minus 4. Okay. So what I've got here is you can do x minus 4, and then x squared plus 4 equals 0. All right. So, home stretch, I can make both of them equal to 0. So x minus 4 equals 0, and x squared plus 4 equals 0. Well, this one's easy. X equals 4, and then x squared equals negative 4. X equals plus or minus 2i, or x equals 4. All right. Now, I have all the work under the sun. Let's go back to see what we're asking this for. Calculate the area of the base of the square pyramid. Guys, you can either have a plus or minus 2i or a 4. You want to use the positive number. Okay? So the area of the base was, when we originally had 3x minus 6 times 3x minus 6, right? Okay? So if I put a 4 in here, 3 times 4, 12. 12 minus 6 is 6. 12 minus 6 is 6. That would give me 6 times 6, which is 36. What are we talking about here? Meters. So 36 meters squared. Is that a difficult problem? Absolutely. But work your way through it, plug in the variables, solve for your x, plug it back in, you're good to go. All right. So good job, everybody. Keep up the good work. And as always, good luck. We're all counting on you.